Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now going to be going through question number 6 from the January 2021 session of the International A-Level Edexcel Pure Mathematics P1 paper. And this question here is part A, is about sketching graphs of functions, and here it says sketch the curve with the equation y equals minus k over x, where k is greater than 0, where k is positive, and x can't be 0, of course. So here we can see I've already made the axes ready for myself to do the sketch. This is the y-axis, this is the x-axis. Now this is a reciprocal function, and the graph of y equals 1 over x will always look like this and like this. It has what's called an asymptote at x equals 0, because we can see that x can't equal 0. It can never equal 0. If x is 0, the denominator will become 0 and will be undefined. So x equals 0 is one of the what's called asymptotes. And the other asymptote is y equals 0. Because if y equals 0, if you try to solve this equation, you're going to have minus k equals 0. Okay, sorry, yeah, minus, if you make y equals 0, you try to solve this equation, not minus k equals 0. If you put y equals 0, what's going to happen is, and you try to solve for x, you have to rearrange the equation. You'll have x equals minus k over 0, which is undefined as well. Okay, so y can't also equal 0, so that means the line y equals 0, which is the x-axis, is also an asymptote. So you have an asymptote which is horizontal, which is the line y equals 0, which is the x-axis, and you have a vertical asymptote, which is going to be the x-axis, the y-axis, sorry, which is x equals 0. So it can never ever get close to those points. Now, when you have y equals 1 over x, when x is, for example, 1, y is 1. When x is 2, y is a half. When x is 3, y is a third. When x is 4, y is a quarter. So as x increases, y gets less. And when x, for example, is a half, y is 2. When x is, for example, 1/10, y is 10. When x is, for example, 1/100th, y is going to be 100, because y is going to be 1 divided by, for example, 1/100th, which is 1 times 100. So as x gets really small, y gets really big. But x can never be 0. So it's going to look something like this, as we've drawn here. And when x becomes negative, y becomes negative. But here we have a situation which is different. It's kind of like this graph, but it's going to be in these two quadrants instead. Because when, for example, just say k was equal to 1 for now. When x is 1, y is minus 1. So when x is 1, y is minus 1. It's going to be down here. Okay, and when x is 2, y is minus a half. When x is 3, y is minus 1/3, and so on. It's going to get closer to the x-axis without touching it. When x is minus 1, you're going to have x is going to be minus 2. When x is minus 10, for example, y is going to be minus 10. Okay, when x is minus a tenth, sorry, when x is minus a half, when x is equal to a half, y is going to be minus 2. When x is equal to 1/10, y is going to be minus 1/10. Minus 10, sorry. Y is going to be minus 10. Okay, when x is 1/10, y is going to be minus 1/10 if it's 1 over x. So just to get the shape of it, it's going to look something like this, and it will never touch the y-axis, and it will never touch the x-axis. It'll have this type of shape. Okay, it'll look something like that. Okay, just to get an idea of its shape. Okay, we don't have to do an accurate sketch, but it has to be something which has the right shape. This bit at the end shouldn't be there. It comes back down. It should be going closer to the x-axis without ever touching it. Closer to the y-axis without ever touching it. And on the side when x is negative, like if x, for example, was negative 1, then y is going to be a positive value. Because you're going to, for example, if k was 1, you have minus 1 over 1 over minus 1, which is going to give you positive 1. When x, for example, is minus 2, y would be plus a half. Okay, when x is minus 3, y would be plus a third, and so on. So it's going to go like this. So it's going to be like the same as the graph above, but just in the other two quadrants. They're switching around. Okay, so this is the graph of y equals minus k over x. Okay, you don't have to draw these points at all. I just did them just to give you an idea of why it looks that way. Okay, so this is the graph y equals minus k over x. Okay, so now the next question, part B, it says on a separate diagram, sketch the curve with this equation. So it's kind of like what we've just drawn, except it's got everything has to be lifted up by k units upwards. So the asymptote, which was y equals 0, now becomes asymptote y equals k. So it's a vertical translation of k units upwards. Okay, this is like f of x plus k. So everything goes up by k units. So it has the same shape. Still x can't equal 0. So this is one of the asymptotes, but there's a new asymptote now. And that new asymptote, which I'll draw in this way, is going to be when y equals k. That's the equation of the asymptote. So that's called the horizontal asymptote. It says the equation of the horizontal asymptote. I've written it down. But otherwise, it's going to be the same two quadrants. And it will look exactly the same as before. Except the asymptote goes up. So now it's going to cross the x-axis at a certain point. Now don't make it do that. It doesn't curve back down. It gets closer to the asymptote without curving back down. Okay, something like that. That should be fine. That's y equals minus 1 over minus k over x plus k. Write that neater. Y equals minus k over x plus k. That's what we had to draw. Okay, y equals minus k over x plus k. Okay, that's the equation that we've drawn. That's the y-axis, that's the x-axis. We have to find this point. It says, stating the coordinates of the point of intersection with the x-axis in terms of k and the equation of the horizontal asymptote. Okay, and in terms of k, the equation of the horizontal asymptote. So this is in terms of k. We've got to find what this point is where it hits the x-axis. Now we know that it hits the x-axis. Anything on the x-axis is when y equals 0. So if I take the equation and I put 0 instead of y, I'll have minus 0 equals minus k over x plus k. If I add k over x to both sides, I'll have k over x equals k. So if I rearrange it, I'll have k over k is equal to x. Therefore, x is equal to 1. So this is the point here, 1, 0. Okay, so we put the point where it crosses the x-axis as 1, 0, and we put the asymptote in terms of k as y equals k. So there's the answer to part A and B of this question. Now we're going to go on to part C. Now part C says, find the range of possible values of k for which the curve with the equation y equals minus k over x plus k, where k is greater than 0, and of course x can't be 0, does not touch or intersect with this equation. All right, so what we're going to do here is we're going to try to set up a simultaneous equation where we're trying to find what the solutions are of these two equations, and we're going to show or find the values of k for which there will be no solution. So the first thing is for me to use some sort of substitution. So what I'm going to do is I'm going to replace the y in this equation. So this is like equation 1 and this is equation 2. So I'm going to substitute equation 1 into equation 2. Okay, that's what I'm going to do. So I'm going to take the y in equation 1 and replace it with 3x plus 4. So 3x plus 4 equals minus k over x plus k. Okay, a lot of people say, oh, you're equating the two. And that's kind of true in a way because they're both in terms of y. But if one of them, for example, was x squared plus y squared equals something, then I'm not equating the two. I'm substituting the y value of 1 into the equation. So that's how you should be thinking about it, because equating them, it doesn't kind of work in that case. The only reason why it looks like we're equating them is because they're both in terms of y. What we're actually doing really is we are substituting one of them into the other. So I'm replacing the y in this equation with what y equals in the other equation. Okay, so now I can solve this equation. First of all, let's get rid of the fractions. Let's multiply both sides by x. So multiply this side by x, you get 3x squared plus 4x. Multiply this side by x, you get minus k plus kx. Okay, now it looks like we have a quadratic. So let's bring all the terms on one side and see what happens here. So we got 3x squared, and you got plus 4x minus kx plus k equals 0. So you've got your x squared term, and you got 4 minus k times x. This is like your x term is 4 minus k, just taking out the the x as common in these two, and I've got plus k. That's like my constant term. Okay, so this is a quadratic equation. Now what we have to say is we got to find the values of k for which this equation has no solution, because we want to find the values of k where this and that will never touch or intersect. So that means they will never ever meet. So if we think about the graph that we just drew on the other side, it looks like this and like this. We're trying to find the values of a line which will, basically, oops. Let me just draw the line like this. We're trying to find the range of values of k for which this line, 3x plus 4, will never meet that curve. We want to find the range of values of k for this such that this line y equals 3x plus 4, which is actually going to be a bit more steeper than that, okay, which will never ever touch or intersect this curve. So it's going to be within that range there somewhere. Okay, so that's what we're trying to find, but we're not doing this graphically. I'm just trying to make you understand what we're doing. We're trying to find the range of values of k for this curve k, 1 over minus k over x plus k, such that the line y equals 3x plus 4 will never touch or intersect with the curve. Okay, so what we need to do is we need to think about this. That means this equation where I equated them should have no solutions. There should be no solutions for this equation, and if that's the case, if there's no solutions for this equation, we should know that the discriminant of this equation, which is given by b squared minus 4ac, has to be less than 0. When the discriminant of a quadratic equation is less than 0, it has no solution, because when you write the quadratic formula, you have minus b plus or minus the square root of b squared minus 4ac over 2a. If this part of the equation, the quadratic equation, this is called the discriminant, because it tells us about the solutions of the quadratic equation. If this is positive, you're going to have minus b plus or minus a value, you'll have 2 solutions. If this is 0, you'll have minus b plus or minus 0, so just minus b over 2a, it will be 1 solution. That will be the case where, for example, the curve and the line is a tangent to the curve, for example. There will only be 1 solution, a repeated root. And if b squared minus 4ac is negative, well, this will be undefined and there will be no solutions. So we can say here that we want to find where b squared minus 4ac is less than 0. That will tell me the values of k for which there will be no solution, because this equation here I made by substituting one of those equations into the other. So here we have our value of a is the coefficient of x squared, which is 3. Our value of b is the coefficient of x, which is 4 minus k. And our value of c is the constant, which is k. So we know that b squared minus 4ac has to be less than 0. So let's make an inequality and solve it. So b is 4 minus k. So you have 4 minus k squared minus 4 times 3 times k has to be less than 0. This will give me 16 minus, I'm going to have 8k, because I'm going to have, if I expand that, I'm going to get minus 8k minus 4k minus another 4k plus k squared minus 12k is less than 0. So let's put everything in the right place. Put the x squared term first. X squared minus 20k plus 16 is less than 0. So I have to try to factorize this or solve this quadratic equation. Having a look at this, the two numbers have to both be negative, okay, and they must both, if you put in the brackets, if we did factorize it, basically what I have to do first, let's just explain it properly. What I have to do now is I have to solve this quadratic inequality. This is called a quadratic inequality. I want to find the values of k for which this is true. Now I can't do it like an equation in terms of just saying, I'm going to have both of them are going to be less than, whatever I get if I have my two factors. No, I can't do that. What I have to do is I have to think about the way this curve looks, okay, and I have to find where it crosses the axis, which you can say this is the k-axis, and this is the discriminant. Okay, I have to find when the discriminant is negative. This is actually an expression for the discriminant. I need to find when the discriminant is negative. I know this type of function is going to be opening upwards, so it's going to look something like this. This is not a sketch of our original function. This is a sketch of the discriminant of our original function. Okay, so we want to find when the discriminant is less than 0. So it's going to be between these two values. Okay, I know they're both positive values because I'm going to end up with k minus something times k minus something. So it'll be k equals and k equals both positive. So they're definitely both positives. I have to find those values. Okay, and I know that my answer is going to be k has to be between those two values. Okay, for the discriminant to be negative. Okay, here the discriminant is positive. Here the discriminant is positive. Here it's negative, and at these two places where it equals 0. So I need to find what these two places are now. So I need to solve the equation k squared minus 20k plus 16 is equal to 0. I want to find where they're equal to 0 first, and then I can decide when it's less than 0. So now this, I don't think it factorizes. I need two numbers that multiply to give me 16. So you got 16 times 1 and 8 times 2 and 4 times 4, and they have to add up to give me 20, and none of them do. So I think this has to be done by either using the quadratic formula or by completing the square. Now we've already used the quadratic formula, so I'm going to complete the square just to give it a bit more, mix up things a bit here. So to complete the square for this, I'm going to have k squared minus 20k equals minus 16. I like to isolate the the term here, like in the x term, or in this case the k term. Keep it on its own, and you end up with k squared minus 20k equals minus 16. Then I'm going to complete the square for this bracket, so I have to write a bracket with a k. If there's a minus here, I put a minus. I write half the coefficient without the k term, so minus 10, and then I square that. Now this will give me k squared minus 20k, but it's going to give me plus 100. I don't want the plus 100, so I'm going to take away 100. So because I took away 100 from, so that's now equal to minus 16. So this is the same as that. This is the same as that. I haven't done anything except change the form that it looks like. If I expand this, I'm going to get k squared minus 20k. Exactly. This will be k squared minus 20k plus 100 minus 100 gives me k squared minus 20k. So, but I've got this square bracket which will help me to solve. So now what I'm going to do is I'm going to add 100 to both sides now to get rid of that minus 100. So I have k minus 10 squared equals minus 16 plus 100, which is 84. So I have k minus 10 squared is equal to 84. Okay, now we can take the square root of both sides. So this becomes k minus 10 equals plus or minus the square root of 84. Okay, you don't forget the plus or minus. And now what we can do is just make a bit more space. Make some space here. So now we can say that k is therefore equal to 10 plus or minus the square root of 84. So we can say that the values of k are 10 plus the square root of 84 and also 10 minus the square root of 84. So if we go back to our little sketch here, that means the one that's k plus root of 84 must be this one. That's k plus, that's 10 plus the square root of 84. Okay, so this one is 10 plus the square root of 84, and this is the other value of k, which is 10 minus the square root of 84. This is 10 minus the square root of 84. So basically we want to find where k squared minus 20k plus 16 is less than 0, where this line is below 0. Okay, that's where the discriminant, this is the discriminant, and so we have the discriminant. Let's draw it again here. This is the discriminant axis. Okay, everywhere above this the discriminant is 0, everywhere below this axis the discriminant is below 0. We want to find the values of k which are below 0, where the discriminant is negative. So here the discriminant is above 0, it goes below 0, and then it goes back above 0 over there. So it's between these two values, that it goes below 0. Okay, it's a bit thick, but no problem. Alright, so we can say that therefore the values of k for which they will not intersect, which is what we have to find, that the line, this line and this curve will not intersect, are the values of k for which the discriminant is going to be negative, which are between the values of 10 minus the square root of 84 and 10 plus the square root of 84. They can't be equals because that's when there will be one solution. That's when the discriminant will be equal to 0, that's when the line will be a tangent to the curve. It can't be positive because there will be two solutions, means the line will cut the curve in two places. This line will cut the curve in two places, okay? And if it's negative, that means the line and the curve won't intersect. Okay, so you can see from here, when if the value of k was equal to, if the value of k was basically equal to this value or that value, okay, that's when there's going to be a tangent. So it's going to be either here or there. Okay, if the value of k was positive, like for example, if the value of k was less than 10 plus root 84, there would be two solutions, cut it in two places. If it was greater than 10 plus root 84, again there would be two solutions because the discriminant is positive. Okay, but if it's between minus 10 root 4, 10 plus root 84 and 10 minus root 84, that's when there's no solutions. That's where the line will not cut or touch the curve. So those are the values of k that we found by using the discriminant. So this is not a sketch of any of the functions. This is a sketch of what the discriminant looks like. When is the discriminant positive? When is the discriminant negative? We're trying to find when it is negative, and the range of values of k. So this is like the discriminant axis, as I mentioned before, and this is like the k axis. Okay, so we're finding the values of k when the discriminant is negative. So it's negative below, okay, between these two values, which we found were 10 minus root 84 and 10 plus root 84. So this is the solution to the problem here, and we're done with this question. If you would like to see other questions on this paper answered in the playlist, is going to appear over here. Other questions about quadratics and about graphs, transformation. Well, graphs basically, it's in the chapter of transformations and graphs in P1. You'll find that in this link over here. And quadratics itself is another chapter, and I'll also probably put a link to that in this section area over here. You can subscribe to my channel by clicking on the link that appears in this area, and on the top of the page here you'll see a card that takes you to some other P1 paper that you might want to watch. Thank you for watching, and I hope to see you soon.